this dividing by longer synthetic division, we have to know some vocabulary or you will be confused. All right, so what if I just said to you, everybody listen, what if I just said to you, take 7 and, whoa, that's like on size 100. Okay. Take 7 and divide it by 2 and give me an answer. The first thing you're doing is you're saying, well, okay, and we're going to be doing polynomial division, but I'm trying to make a point with this. So if I said, what's 7 divided by 2? You'd say, and you'd give me a decimal. And I'd say, okay, let's like write it differently. How many times does 2 go into 7 perfectly? 3 times. This is what they call the quotient. So the quotient is the part that is perfectly into it. Now we know that that doesn't really multiply to be 7. 2 times 3 is 6. So how many are remaining to get back to 7? 1. Now, if you do 3 plus 1, that's 4 equals 7/2, which is wrong. That's not right. So how do we make this an actually true statement? Well, remember, you don't just write remainder 1. Instead, you put the remainder over, right here, over the divisor. The divisor is what you're dividing by. We're dividing by 2. So it would actually be 3 plus 1/2, which now is a true statement. 7/2 is 3.5, and 3 plus 1/2 is 3.5. So does everyone see how you do it? You divide it, you figure out what goes into it perfectly, you write the remainder, and then you put the divisor back in under the remainder. Now watch, because this is how they want you to write your answer today. What if they said, okay, there's your answer, but write it as the product of 2 factors and its remainder. Basically what they're saying in a fancy way is, write this in a different true statement. Get rid of divide by 2. So mathematically, if you want to get rid of divide by 2, couldn't you choose to multiply the 2 over to this side? Mathematically, yeah? That's what undoes division, is multiplication. Now, because there's a term here and here, watch so that it's not confusing when I do this with polynomials, you'd say, I need to multiply 2 to this and this. And now this 2 would be gone. So now watch. What would the answer now look like? Well, it would, don't say 6. Let's write it out so that we're not confused. We have a 3 times a 2 from that piece, correct? Mm-hmm. And then we're going to have plus, and then look, the 2 and 2 will divide out. So we'll have plus 1. See, this would be the product of the 2 perfect factors plus its remainder. Now, isn't that still a true statement? Does that equal 7? See, we moved the 2 over, so now it's just 7. Is that also a true statement? 3 times 2 plus 1 is 7, yes. Okay, so they call this, they have this answer like this. So, like, look. So here's a polynomial. They're going to say P of X. We're not learning how to divide yet. We're learning how to write our answer. Okay, so if I say take this P of X and divide it by X plus 3, they're going to call this D of X, divisor. So then you're going to go through and do the process of long or synthetic division, and you're going to get an answer. You're going to have the part that divided nicely, which is called the quotient. I'm going to put it in parentheses. Then you're going to have your remainder. So notice my remainder is written over the divisor. Does everyone see where I'm getting all this? Not where I'm getting the answer, just looking at the answer. Yes, yeah or no. Okay, but that would just be the like, oh, there's my answer. A lot of times today, annoyingly, they're going to say, write your answer in this format. See, look, they've taken it from, this is the straightforward answer. See, it said P of X divided by D of X is a quotient plus the remainder, and I forgot to write divided by D of X, like that. I forgot to write in the D of X. Anyways, so that is just the straightforward answer. They want you to convert it to this answer right here. So look what they did. They did what we did above. They took D of X and they multiplied it over. See, watch. D of X times D of X. So now, isn't it just Q of X times D of X? Yes? And then look, these D of X's divide out. So you'd have plus the remainder. So you'll have the quotient times the divisor plus the remainder. They like this format of the answer. They like it written as a product plus its remainder. And I'll explain why in a minute, why I think they like that, the format of that answer better. So look how we would write this. We would take our X plus 3 and we would go like this. I'm going to multiply it over to this side. So now it's gone. So I had to multiply it to this. It's squishy, so just stick with me. And this. Now we're not actually multiplying it out. We're just writing it. So we have 2x squared minus 11x plus 32 times x plus 3. I'm writing it as a times problem. Everyone's seeing it. And then we have, and then this x plus 3 up here is going to divide out with this x plus 3 down here. So then won't you just have minus 93? They like the answer in this format. Here's why I think they like it in the format. The whole reason we learned synthetic division in the first place is we're trying to test if things are solutions. Like is right here x plus 3. If this is a factor, then -3 must be a solution. True, everyone? Now we know since there was a remainder of -93 that -3 wouldn't be a solution. If this truly was a solution, your remainder would be 0. It would divide perfectly with a remainder of 0. So I think what they like is if this was a solution and they ask you to write it in this format, you now have it in factored form because you won't have anything here. It'd be a remainder of 0. So it's just like another factoring technique, essentially. Okay, so let's see what I mean by this. It'll make more sense once we actually start doing it. So I'm going to remind you how synthetic division works, my friends. You're going to take the divisor. I'm just going to call it D, divisor, and you set it equal to 0. We then solve for x. X equals 3. With synthetic division, this process is a memorization process, and we use the solution of the divisor with synthetic division to divide. So we put this 3 and we draw this kind of little housey visual aid. We then put in coefficients. Now remember, this is what you have to do with synthetic division. You're going to start with your leading term, but before you move on, you're going to check, okay, if my leading term is x cubed, do I have a placeholder for every value of x after that? X cubed, x squared, 0x. With synthetic division, it has to have a placeholder for every degree of x. Okay, so write a 5, then a -2, then a 0, then a 1. If you forget your 0, you're going to get the wrong answer. Add straight down. This is how synthetic division works, remember? Add straight down. So the first position will never have anything to add to it. Add straight down, you get 5. You then always take that number and you multiply it back up to this 0, which 5 times 3 is 15. We then place it under the next coefficient. We always add straight down. So isn't that 13? Where did my 1 go? It disappeared. This pen like erases things. Then we might take that 13 and multiply it up to the 0. So isn't that 39? Mm-hmm. Add straight down. Multiply up. 117. So you're right, 118. Now here's where I don't recommend saying, oh, well, that's the remainder. Okay, yeah, it's going to work most of the time because most of the time you're not going to mess up. The problem is you can't catch if you made your error if you do it backwards like that. So I used to, in my first few years of teaching, teach kids like, so this is always the remainder, then work backwards. Constant x squared. Here's why I don't recommend that anymore. If you do it that way, you'll never catch if you forgot a 0. If you do it this way, the other way, this way I'm going to show you now, you'll catch, oh, what the heck, I'm not ending at the remainder. Oh, I must have forgot a 0. So watch, what you should do instead is say, okay, so if I have 5x cubed, and that's the leading term, and I'm dividing by leading term x, that'll now be 5x squared. This should be the first term in my statement. Do you guys see? So you go, oh, 5x squared. Then you'll work your way down. Plus 13x plus 13, which after 13 would come the remainder. So we would then say plus 39. I wonder what's up with my pen. It keeps erasing stuff. So then plus 118 over the divisor. What's the divisor? X minus 3. The divisor is still x minus 3. We just use the... Remember that synthetic division is just a trick to dividing. So it's still this answer. Now, what if they are like, cool, that like if they just say divide, like that is your answer. But what if they say to you, write your answer as Q of x, Q of x times D of x plus R of x. So they're saying instead, do the quotient times the divisor plus the remainder. So let's go put parentheses around the quotient. The quotient was the part that divided nicely, so that would be that part. So you'd say, okay, so my quotient is 5x squared plus 13x plus 39. I'm then timesing it to the divisor. What was the divisor? X minus 3. And then we're adding our remainder. So it would just be 118. Just 118. You don't put the x minus 3 in anymore because a minute ago I just showed you the math on it. When you multiply it up, the x minus 3 would divide out. Yeah. So that's how they like the answer. So now here's how we use this, okay? So this whole point of today's lesson is so we can use it like this. So now we know for a fact that positive 3 x equals 3 is definitely not a solution to that polynomial. If it was, the remainder would have been 0. If it really is a solution and x-intercept, it divides perfectly. Does that make sense, everyone? So we can rule out 3 as a solution. Okay, moving on. All right, so looking at this one, same thing. You'd say, okay, I take the divisor and I set it equal to 0, and then I solve. So x equals -2 is what I'm using. I then put a coefficient of 1, but then I'm missing 0x squared plus 0x. So 0, 0, and then after x comes the constant, which is 8. Okay, here we go. Add straight down, multiply up, add straight down, multiply up, add straight down, multiply up, add straight down. Okay, now I'm going to do it again. X cubed divided by x is x squared. So this should be 1x squared minus 2x plus 4. The remainder comes after constant, so we ended up in the right spot, so I didn't forget any zeros. So it divided perfectly. So let's now make a conclusion here. X equals -2, what? Must be a solution to x cubed plus 8. All right, I was just pointing that out because that's how we use this. Now, what if they said, write this in factored form? Oh, actually, yeah, let's go do it. Like if they said, you know, if they said q of x, I'm not going to rewrite it. It's right here. If they want it as quotient times the divisor plus the remainder, let's do it. This would be our quotient. X squared minus 2x plus 4 times the divisor, which was x plus 2, plus the remainder. For dramatic purposes, I'm writing plus 0, which we know is not necessary. But see, look, now that's kind of like a factoring technique. Didn't we now just like factor it at least one step? Yeah, and then we could check, oh, does this quadratic factor? But my point is, it's kind of used today as a factoring technique. Okay, cool. So we'll move on. Now I need to be very clear. So listen, because last period, this is where it kind of started to go downhill, I feel like. So would you guys agree that I have drawn 2 polynomials, one that's in pink and one that's in green? Yes? Now notice they all have the exact same x-intercepts. They both do. True? Yeah. They have the same x-intercepts. They're just totally different polynomials. That can happen. So here's the thing. To use synthetic division, the rule is, and we probably should have wrote this rule down to begin with, but to use synthetic division, your denominator, your divisor, has to be leading coefficient of +1 and exponent of 1. If you want to use synthetic division to divide polynomials and get the right answer. So notice in all these examples they just gave us, our divisor had just the divisor. The leading term the leading polynomial doesn't matter. But look, the divisor has a power of 1, leading coefficient of 1. See? Power of 1, leading coefficient of 1. That is just a rule to getting the correct answer. If you try to use synthetic division and it's not that, it's not going to give you the right polynomial. Now here's the question though, okay? So look at this one. So can we use synthetic division here? No. Let's reorder this if you don't mind real quick. -12x squared minus 8x plus 4 divided by 2x minus 3. Okay, that's better. So you're right. Because this is not a 1, if we use synthetic division, we are going to get the wrong polynomial. Now I guess here is the thing though. You actually can test something. You actually can use synthetic division. The question is, like, what's the purpose? Are you dividing this to test if this is a factor, if this is a solution? Because if so, you actually still can use synthetic division. Because you would just be testing zeros. It'll be so do you guys see what I'm saying? Like, it'll be the wrong polynomial, but they have the same zeros. So if the purpose of testing is, let's see if negative, go back, set it equal to 0, 2x minus 3 equals 0, add 3, divide by 2. Let's see if 3/2 is a solution. You are allowed, if that's your purpose is this a solution? You're allowed to do synthetic division. Does that make sense? Now, if they ask you, what is the polynomial? If you do synthetic division, you'll have a polynomial with correct x-intercepts, but it's the wrong polynomial. Is it making sense what I'm saying? So if you need the correct polynomial, if you're not just testing, is this a solution? You need the correct polynomial, you have to use long division. because it will give you the correct polynomial with the correct x-intercepts. Okay, so let's go do long division. We need to remember how to do long division. So remember with long division, we set up the divisor on the outside of a dividing house. We then put in our dividing house the polynomial, so we put negative 12x squared minus 8x plus 4. All right, and now from here, we need to remember the process of long division. So listen, because it is a long process. Some of you do it a different way, which is fine. Once again, though, I personally do it this way because for hard problems in the, like at your guys' level, for the most part, the way your teacher last year taught you will work. But I just do it this way since this works for even really, really advanced ones. Anyways, so we have negative 12x squared. When doing long division, we take the leading term divided by leading term. So negative 12x squared divided by 2x. That's negative 6x. Do you guys agree? So now we put negative 6x up here. We then take that and multiply it back down to this and this very carefully, because you make one sign error, the whole thing's wrong. I kept having people calling me over saying, I think you made an error here. And I actually hadn't. I do make errors, but I hadn't made an error. They had, but I do make errors. A1, bless their souls, they do catch all my errors before you guys get here. So that's negative 12x squared. 6x times negative 3, isn't it positive 18x? Now you have to remember, with long division at this point, you then take that thing you just multiplied and put underneath and you change the signs on it. Whatever they currently are, they need to be changed to the opposite sign. Since this is minus, it now needs to be plus. Since this is plus, it now needs to be minus. Now listen to what I'm verbally saying, because this was still throwing people off last period. You are now going to combine like terms underneath. They do not have to line up. What's x squared over here and 20x squared over here? Still 21x squared. You guys see what I'm saying? Like, they don't have to line up. Okay, negative 12x squared and 12x squared become no x squareds.
Don't they, if you're doing it right, don't they usually cancel out?
Not always. Oh, these? Yes, sorry. I'm so sorry. When you said that, my brain went right to what you were going to say, and I thought I was reading your mind, and that was not what you were going to ask. I thought you were going to ask, if you've done this right, won't they line up? And they won't always line up.
Because there could be like a gap.
Yeah, there could be a gap, and there could be an x squared on top. It just doesn't. You'll see on the homework where if you're doing long division, some of them don't line up. Okay, but you're not wrong. You're right. If you've done this right, the leading term will always cancel out. Yes. Okay, so now we have negative 26x, I believe, because negative 8x minus 18x, and then plus 4. Now we just start the process over. Bulletin point. You do leading term divided by leading term. So negative 26x divided by 2x is negative 13. I then need to multiply negative 13 back down, because that's the leading term, and that's what we always do. Oh, are you asking why it added up to be negative 26? And then I can re-explain what you're actually asking. So we had a negative 8x and a negative 18x, which adds up to be negative 26x.
Oh, okay.
Uh-huh.
That makes sense.
Yeah. So now we're doing 13 times 2x is negative 26x. Negative 13 times negative 3 is positive 39. Do not forget to change the signs at this point on all of that statement. So that'll now be a plus and a minus. So when I add straight down, I get negative 34. Yeah?
35.
Yes, I do. Negative 35.
That's 13.
Now we know that's the remainder, because once the x's stop dividing nicely, see the x's divide nicely, the x divides nicely. Once the x's stop dividing nicely, the rest of it is your remainder. So we know we write it like this. Let's put our quotient in. This is our quotient in parentheses. We're then timesing it by the divisor. Wasn't that 2x minus 3? And then we add our remainder. So plus negative 35. Or we could just write minus 35. That would be how they like the answer today. So the answer is 3/2 a solution to the original polynomial? No, guess what? If we were just testing that, you could have done synthetic division and it would say no, and it would be fine. I'm just reiterating that you can still use synthetic division if all you're doing is trying to find if it is or isn't an x-intercept. Okay, good. All right, moving on. So watch, the factor theorem is just using that to factor. Like, it's just like saying, here's another factoring technique. Like, look. So they're saying, okay, if this is for sure a factor, can you factor it completely? Well, yeah, look, couldn't we go do synthetic division and get this to a power of a quadratic? And once we have a quadratic, can't we for sure factor it? Do you guys see what I'm saying? So it's just another factoring technique because look, when we have 4 terms, 1, 2, 3, 4, we can try grouping, method grouping, but this doesn't work here. If I pull out an x squared, left is x minus 2, GCF of -1, left is 5x plus 6. If method grouping is to work, these would have had to be the same. So you're like, oh, nope, grouping doesn't work. That doesn't mean it doesn't factor, it's just that method doesn't work. All right, so let's go use the factor theorem. It says in the instructions, is this a factor? So let's go see if it is. So we're going to set x plus 3 equal to 0 and solve. X equals -3. Let's go test it. 1, -2, -5, 6. Add straight down, multiply up. Add straight down, multiply up. Did I mess up yet?
No.
Add straight down. Is the remainder 0?
No, maybe.
Not 0. I don't even care what it is because I'm answering their question. So I'm just not going to bother. You know what I mean? They said, is this a factor? You'd say no. The remainder would have been 0 if it was. So it says, is this a solution? No. So you can't factor it. Like with the tools in our toolbox, then if that's not helpful, then you can't factor it because grouping didn't work. And then they didn't give you one that would get it down to a quadratic. So you're going to say, I can't factor it with that information. I'm not saying it doesn't factor, but today you wouldn't be able to factor it. Okay, move on. So same thing here. It says, is this a factor? Is this a solution? So you would say x equals 4. You would go through and do synthetic division, right? 3, -2. What am I forgetting here? 0. Add straight down, multiply up. Add straight down, multiply up. Add straight down, multiply up, add straight down. I get a remainder of 10. So answer it. Is it a factor? No. Then is 4 a solution? No. So you're going to say, well, I can't factor it with that information then. All right, so now we'll be able to actually use it. See, look, this time, this example, they're giving you one that works. Now, they told us in the instructions, this is a 0. So you know for a fact that is a solution. So when you go divide it down, if you don't get a remainder of 0, you messed up. So it says, let's read the instructions. It says, use the techniques of this section to find the zeros and factor it completely. So basically, they want the solutions and factors. Let's go for it. Once again, if you try grouping and it works, cool, do it that way. But grouping doesn't work in this case. Actually, does it? It actually might. Do you want to do grouping?
Yeah. X squared.
Pull out an x squared. Left is 2x plus 1, yeah? Pull out a -1. Left is 2x plus 1. Pull out our 2x plus 1. Left is x squared minus 1. I mean, that's why we have all these tools in our toolbox to make our life easier. So now, that's a perfect square root. True? So we have our 2x plus 1. And then it factors to be x plus 1, x minus 1. We square root this, remember? We square root this, and then they factor to be conjugates. So, I mean, yeah, grouping worked there. Let's do it. So now it said factor it. Well, we've done that. And then it says then find the solutions. So we would set these equal to 0 in our head and solve. So -1 divided by 2 is -1/2, -1, and 1. Because it asked in the instructions to also find the zeros, the solutions. Okay. So what could have happened is, let's say you forgot that. What you would have done is divided it down with 1. See, watch. 2, 1, -2, -1. Add straight down, stick with me. Multiply up, add straight down, multiply up, add straight down, multiply up. Do you guys see how I get a remainder of 0? Yeah. Then you would have said, since I have divided it down one time, it used to be power of 3, now it's a power of 2. Watch. 2x squared plus 3x plus 1. Now you'd say, well, okay, currently I have this factor. I have an x minus 1. How do I know I have a factor x minus 1? X equals 1. So you'd work backwards, yeah? Okay. And then you would say, and currently I have 2x squared plus 3x plus 1. The real question is, does this quadratic factor or not? You would then do a times c, adds up to be b. Well, multiplies to be 2, adds up to be 3, 1 and 2, 1 plus 2. You'd have to long factor it, drop and break, and then we would get to that same answer.
But
So that one's a bigger pain in the butt than grouping.
It said divide until you get a quadratic, so you wouldn't be able to group, right?
I mean, the thing is we're answering what it says, which is find the zeros and factor. So I don't think the method matters.
Yeah, but in like the Reddit says divide until you get a quadratic.
That's just me giving you a suggestion. Because can't we always factor a quadratic if we can get it down to a quadratic and solve it? Yeah. Okay, you'll see why I do it. Yeah.
It was red, so that makes it seem like it's.
So you
Okay,
always
sorry.
need to put the quotient, which is x minus 1 or whatever, not quotient, the divisor, x minus 1 in front when you're doing that thing. So I almost forgot that. When you do the
Yeah.
factoring at the end, you
Oh.
always had to put it in front.
No, it doesn't matter where it goes. Like, order doesn't matter. Yeah, because it's multiplication. Okay, let's do it again. Go again. Okay, this one I'm going to use division. I'm not going to factor it because grouping doesn't even work. So we have no choice but to use this information. So we're going to start with 1/2, do synthetic division. That's how we use zeros to factor, was we try to get this down to a quadratic. So 2, -3, -11, 6. Add straight down. Now, when fractions happen, they really aren't as bad as you think they're going to be. Just watch. So you add straight down and multiply up. 2 times 1/2 is 1. Add straight down. Multiply up. -2 times 1/2 is -1. Add straight down is -12. -12 times 1/2 is -6. Add straight down, we get 0. If we didn't get 0, we know we messed up because they told us this should be a solution. Now from here you'd say, because this needs to be your thought process, it's not always going to be quadratic at this point. You're going to say, what did I even start with? An x cubed. I've only divided it down one time.
Wait.
So that goes from x cubed to x squared.
How do
Yes.
you know it's going to be a perfect solution?
Because it says it right here, 0. This is a 0. Okay. So now from here you would say this, 2x squared minus 2x minus 12. That's what we get. So I just want to be clear here. So far, we have factored it to this point. Be careful because let me show you what kids do. Let's write the factors. A lot of kids will call the factor x minus 1/2. They'll subtract 1/2. Now, are they wrong? Technically, no, but that's not how we should be doing it. Instead, we should be timesing by 2. 2x equals 1, and then minusing 1. 2x minus 1. We want these pretty non-fractional factors. Those both have the same solution. Isn't 1/2 a solution for both? But we're going to want the non-fraction one. So to be clear here, okay, to be clear, we have the factor of 2x minus 1 and 2x squared minus 2x minus 12. That doesn't mean I'm factored completely. That's just so far. Are we all good?
Yeah.
Then you're going to say, okay, does this factor further? So I'm good with the 2x minus 1. I'm ignoring it. Isn't there a GCF? Then I'm definitely going to pull that out so I can hopefully quick factor if it ends up factoring. So pull out a 2. Left is x squared minus x minus 6. I would say, okay, now I can factor a times c adds up to be b. Good. -6 and adds up to be -1. 3 and 2, -3 and 2, he says. It works there. And then double check. Yes, I can quick factor because my greatest common factor doesn't matter now. So I have a 2, and then I quick factor it to be these two things with an x. X minus 3, x plus 2. So we have this factor. Look. We have this factor, this factor, this factor, and this factor. Order doesn't matter. In my opinion, it feels weird to have a 2 in the middle. It just feels weird. It's not wrong. It just is weird. So I'm going to put 2 in the front. 2x minus 1, x minus 3, and x plus 2. Order doesn't matter. Multiplication can be reordered in any order. You were doinking around instead of listening.
Guys, relax.
All right, let's do another one. There's a reason I'm doing this one. Look, they gave us 2 solutions. Why did they do that? Well, look, what's the power? 4. We actually don't know how to factor a power of 4. We have never learned a factoring technique. Like, this doesn't have 4 terms. It has 5 terms. So it's like we've never learned a factoring technique. But they're giving us 2 solutions. So think about it. If you're at power 4, if you can divide it down twice, won't you get to a quadratic? And quadratics are something we can always handle. All right, let's do it. Let's start with -2. We're going to divide it down. 1, -2, -11, 6, and 24.
So you have to do it for 4 as well.
Yes, because otherwise, unless we can get something down to if we get down to where we can factor it, we don't have to keep dividing it down.
Does it matter which one you divide by first?
It doesn't. Add straight down, multiply up, 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 add straight down. Remainder of 0. Which should be, because -2 is a solution. Now, here's the thing, okay? So you could check if you want, at this point, can I factor my answer instead of having to keep dividing? So if we went from power 4 and down once, this would be x cubed minus 4x squared minus 3x plus 12. Now it's only 4 terms. Could you try grouping?
Yeah.
And grouping actually works here. But I want to pretend for kicks and giggles because it won't always work here. I promise. At this point, there's going to be, most of the time, grouping won't work. So what I would do is say, let's pretend it didn't work. Or you didn't recognize it. Then you'd say, okay, well, then I don't know how to factor it, so I'm going to divide it down again. Do not go back to the original coefficients. You have to stay with these new coefficients because we're trying to get it smaller. Listen, anytime you divide, these still will be solutions of every new polynomial. So you don't have to go back to your originals. Let's use those. So let's do 4 and use coefficients 1, -4, -3, and 12. Add straight down, multiply up. Whoa. My brain is, yeah. Okay, add straight down, multiply up, add straight down, multiply up, add straight down, 0. Okay, now you were at power of 3. Aren't we now at power of 2? X squared minus 3, because there's 0x. So x squared minus 3. So once again, I'm trying to stay very clear so no one gets confused. I currently have factor what? That's solution. I have factor what? X plus 2 and factor. And now a quadratic x squared minus 3. Now they say factor it. Isn't that as factored as it gets?
Yes.
This doesn't factor. A times C adds up to be B. No, it doesn't factor. So that's as factored as it gets. In the instructions, I just want to say, sometimes they'll say, leave your answer as linear and irreducible quadratic factors. So look, linear and irreducible quadratic. That means a quadratic that doesn't factor. But they did say find the solutions. So now we're going to set this equal to 0 and solve. So we get x equals -2 and 4. And then I'm going to have to do some math. X squared minus 3 equals 0. I'm gonna solve this quadratic by taking square roots. So I'm going to add 3. Square root. X is equal to plus and minus root 3, which is a decimal, which means it does cross the x-axis, so those are also considered real solutions. So you'd say plus and minus root 3. If it is power of 4 and they want the solutions, you should have 4 solutions.
Oh, that's 4.
Yep. Are we all good? Okay, moving on. Okay, right here, almost finished. We really are. Stick with me though. They said, given this graph, factor this and find the solutions. We don't have, look, grouping doesn't work. So the only method we know right now is we pray that we at least have one solution we can divide this down with. Look over here with your eyeballs. Decimal, decimal, whole number. We're going to pick 5 then. 1, -11, 37, -35. This one's going to go quick. Add straight down, multiply up, add straight down, multiply up, add straight down, multiply up, add straight down. Okay. Alrighty. Stick with me here. So you're like, okay, I went from power of 3. I've divided it down 1 time, which means I'm at power of 2. X squared minus 6x plus 7 equals 0. There'll be a student who makes the error. Even I, on the homework, messed up on one of my factoring because I just was going too fast, just like we all do. A times C adds up to be -6, and I did the same thing. I went, okay, that works. 1 plus -7 works. But that doesn't work because, look, 1 times -7 is not +7. You guys see what I'm saying? So it's like, well, are there other factors? No. That doesn't mean it's not solvable. It's just not solvable by factoring. So this is a quadratic that's irreducible. So if they say factor it, we have answer x minus 5, since 5 is the solution. And we have the irreducible quadratic of x squared minus 6x plus 7. That's as factored as it gets, but we know we should have 3 solutions. So now let's do the quadratic formula. That's why they had a whole day where it was like, hey, get good at the quadratic formula so that when we get to finding solutions today, it's just quick.
How did someone figure this?
X equals negative b, that would be 6. Plus and minus the square root of b squared is 36, minus 4 times 1 times 7, all over 2 times 1. 6 plus and minus the square root. I'm going to go type that into my calculator, and I get 8 all over 2. I then say I need to do square root of 8 by hand. That's 2 times 2 times 2. 2 roots of 2 is the better version of root 8. 6 plus and minus 2 roots of 2 all over 2. We then learned last time it's a good idea to split it up. 6 halves plus and minus 2 roots of 2 halves. So what would be our answer? My solution is x equals 3 plus and minus square root of 2. Because look, 6 divided by 2 is 3. 2 and 2 divide out. So now you would go up to the box of solutions and say I have x equals 5. X is equal to 3 plus and minus root 2, which we know are decimals. You could then check, oh, are those landing in the correct location? You could type into your calculator 3 plus root 2 and see, oh, yeah, that is the decimal of that. Okay. Do you guys feel like you need another example where you're like, we get the picture?
I've never watched Thunder Vision.
Well, shut up. Just kidding.
That's on video.
I know. I'm glad it's on video so he can remember this. All right. All right. Now we're learning something else. The remainder theorem. Listen, because this is not hard or confusing at all. In fact, this is the easiest part of the lesson, and people overcomplicate it and miss it on the test. So listen, the remainder is very important to us. Would you agree? The remainder is very important to us. Why? Because then we can tell if something is or isn't a solution. Are you with me? So how can you find the remainder? Well, I prefer synthetic division. Look with my eyeballs. But there is another way. It's the remainder theorem. So let me explain the remainder theorem. If you want to find the remainder and you don't want to do synthetic division, instead of taking the bottom and setting it equal to 0, which we still need to do, and solve, instead of doing synthetic division with that number, you actually literally can just go plug it into the polynomial, and it really, truly, every single time calculates to be the same value as the remainder. So you can just go plug it in. 2 times negative 1 squared plus 3 times negative 1 minus 1, which is 2 times 1 minus 3 minus 1, which is 2 minus 3 minus 1, which is negative 2. The remainder will be negative 2. I'm going to prove it to you because I'm going to do synthetic division. So I'm going to use negative 1. Instead of plugging it in to find the remainder, I'm just going to use synthetic division. 2, 3, negative 1. Add straight down, multiply up. Add straight down, multiply up, add straight down. Do you guys see? It's just 2 ways of getting the remainder. So my question is, what do you prefer? The remainder theorem says you just plug it in. Synthetic division. I way would rather do synthetic division. Look how much quicker it was. But that's just me. I'm not saying you have to pick what I pick. Okay, so it says, is this a factor? No, the remainder is not 0.
Will there be a question that says, like,
Yes. So look at this problem. And this is my last problem of the day. See, look, this is how they word it. It says, find P of negative 2 and using the remainder theorem. That, by definition, is the remainder theorem. Didn't I just say plug it in? We'll give you the remainder, everyone, yes? So that's what you're like, that is the remainder theorem. Let's go plug it in. 2 times negative 2 cubed minus 5 times negative 2 plus 3. So then that would be 2 times negative 8 plus 10 plus 3. Negative 16 plus 10 plus 3 is negative 6 plus 3 is negative 3. So you would say my remainder is negative 3. So the question is negative 2, is negative 2, x equals negative 2, a solution to this polynomial? No, the remainder wasn't 0. They forced you to do it with the remainder theorem. I freaking hate the remainder theorem. I'd way rather do synthetic division. Are you asking what as in like why do I hate it, or what as in okay. I didn't know if you were confused. Okay. Now read the next one. It says, use the fact that x equals 1 is a 0 to find all the real zeros. So I'm going to definitely use synthetic division, get it down to a quadratic. So I'm going to put coefficient 2, 0, negative 5, 3. I'm putting 0 because there's 0 x squareds. Watch, add straight down, multiply up, add straight down, multiply up, add straight down, multiply up, add straight down. So now we have 2x squared plus 2x minus 3 equals 0 because it wants us to find all the real zeros. So you'd say, now that I have a quadratic, I need to solve. Okay, so x equals negative b plus and minus the square root of b squared. That would be 2 squared is 4 minus 4 times 2 times negative 3 all over 2 times 2.
Wait, why did we just go straight to the quadratic formula? It didn't work.
Come on, look at- I need you to-
We could try and factor it. What multiplies to be negative 6 and adds up to be 2, nothing. So you're right, I did skip
You
that.
just went quicker than me, that's all.
No, that's fine. So then I have 4 plus, what is that? I can't do that right now in my head, just stop judging me. 4 minus 4 times 2 times, yeah, 28. 28 all over 4. You go off to the side and say square root of 28 is 7 times 4, which is 7 times 2 times 2. So 2 roots of 7 is the better version of root 28. So then your final answer would be, okay, negative 2 fourths plus and minus 2 fourths roots of 7. So our solutions are negative 1/2 plus and minus 1/2 roots of 7. And there was another solution. They gave it to you, wasn't it 1? Okay, that's the end of my lesson. So you're just today using synthetic division to like factor things and to find remainders, and then they make you do long division because there are some that will not do synthetic division. So, yeah. Okay. And then in the next lesson, we use synthetic division a lot next time I see you. Okay, cool. Ready, set, go.